Right now, as you sit here, light is arriving from the edge of the universe, not from the edge of space, not from the edge of reality, from the farthest place we can ever see. Every second, photons that have traveled for billions of years are finally reaching Earth. They left when the universe was young, when galaxies were still forming, when Earth did not exist. That light has crossed expanding space, survived cosmic radiation, passed through empty voids larger than imagination, just to arrive here. Tonight, we are standing at the limit of observation, because there is a boundary, a horizon. Beyond it, the universe still exists, but no signal can ever reach us, no matter how powerful our telescopes become, no matter how advanced civilization grows. Space itself is expanding faster than light can travel. Objects beyond that line are disappearing from our universe forever. Not destroyed, not gone, just unreachable. Right now, the observable universe is about 93 billion light years across. That number is not the age of the universe. The universe is only 13.8 billion years old. So how can we see something 46 billion light years away in every direction? Because space is stretching. While light travels, the distance grows. The universe expands underneath the photons. We are watching ancient light from places that no longer exist where they once were. Galaxies we see today are already much farther away now. Some are already beyond recovery. Their last photons are arriving, their final messages, silent farewells crossing cosmic time. Tonight, we are going to travel outward, past the Milky Way, past galaxy clusters, past the cosmic web, past the last visible structures, to the edge of everything we can ever observe. Not science fiction, not speculation, a real physical boundary built into reality itself, the horizon of the universe. Let's begin. The universe did not always have an edge. In the beginning, there was no horizon, no boundary, no visible limit. Everything was compressed into a region smaller than an atom. Energy, matter, space itself. Then, 13.8 billion years ago, the expansion began. Not an explosion into empty space, but space itself expanding everywhere at once. There was no center, no outer wall. Every point moved away from every other point. At first, the expansion was violent. Space stretched faster than light, much faster. In a fraction of a second, the universe grew larger than galaxies would ever become. This period is called inflation. It shaped the largest structures that would ever exist. Tiny quantum ripples were stretched across cosmic scales. Those ripples became the blueprint of everything: galaxies, clusters, voids. When inflation ended, the universe slowed. Radiation filled space. Particles formed. Atoms appeared. Light was finally able to travel freely. That light is still traveling. It is the oldest light we can see. The cosmic microwave background. A faint glow coming from all directions. It is not coming from a place. It is coming from a time. From when the universe was only 380,000 years old. That ancient light defines our first visible boundary. Beyond it, the universe was opaque. Hot plasma blocked all photons. We cannot see earlier than this, not because the universe did not exist, but because light could not escape. This is our first wall. But it is not the final one. As time passed, gravity began shaping matter. Gas collapsed, stars ignited, galaxies formed, clusters gathered, cosmic filaments stretched across millions of light years. And while all this happened, space itself kept expanding, not slowing forever, not stopping, accelerating. About 5 billion years ago, something changed. The expansion began speeding up again. Scientists named it dark energy. Not because it is dark, but because we do not understand it. Dark energy does not pull. It pushes. It stretches space itself. And it is winning. Every second, distant galaxies move farther away, not through space, but with space. At small scales, gravity holds things together. Stars remain bound to galaxies. Galaxies remain bound in clusters. But beyond a certain distance, expansion dominates. Space stretches faster than gravity can resist. This creates the observable universe, not a physical wall, not an edge you can crash into, but a horizon, a limit created by time and expansion. The observable universe is not everything that exists. It is only everything that has had time to send light to us. Imagine standing in the middle of a vast ocean. You can only see as far as the horizon. Beyond that, the ocean continues. But light cannot reach your eyes from farther distances. The universe works the same way, but on scales beyond imagination. The observable universe has a radius of about 46 billion light-years. That means the diameter is roughly 93 billion light-years. Yet the universe itself is only 13.8 billion years old. This seems impossible. How can something be farther than light has had time to travel? Because space stretches while light is moving. Photons begin their journey when galaxies are much closer. But during their travel, the universe expands beneath them. By the time the light reaches us, the source is now vastly farther away. We are seeing ancient positions, ghost images of the past, galaxies frozen in time. Some of those galaxies are already gone from our future. Their light will never reach us again because they are crossing the cosmic event horizon. This is the true hard limit. The cosmic event horizon is not the same as the observable edge. It marks the boundary of future visibility. Objects beyond this line are permanently disconnected. Even if they emit light forever, that light will never arrive. The space between us and them expands too fast. They are being carried away by the fabric of the universe itself, silently, relentlessly. Right now, billions of galaxies are slowly disappearing from causal contact. Not dramatically, not suddenly, but steadily. As time passes, fewer galaxies remain visible. In trillions of years, only our local group will remain observable. Everything else will fade into darkness. Future civilizations may never know other galaxies existed. They will see a lonely island universe and believe it is all there ever was. This is not science fiction. This is the predicted future of cosmic expansion. The universe is not only expanding outward, it is isolating regions of reality, breaking the cosmos into unreachable islands. But what lies beyond the observable boundary right now? The honest answer is simple. We do not know. Physics allows possibilities. The universe may be infinite, stretching endlessly in every direction. Or it may be finite, but unbounded, like the surface of a sphere, without edges but with limited volume. Or it may be part of a much larger multiverse structure, where our observable region is only a tiny bubble. We cannot directly test these ideas because no signal from beyond the horizon can reach us. This is the hardest limitation science has ever faced. Not a technological problem, not a funding problem, but a fundamental boundary built into reality. Even with perfect instruments, perfect detectors, an infinite patience. We cannot see beyond the cosmic horizon. Information simply cannot cross it. This changes how we think about knowledge. In everyday life, limits exist because of weakness. Our eyes are weak. Our machines are imperfect. But this boundary exists even for perfect observers. It is not about human limitation. It is about the structure of space-time itself. Reality has a built-in privacy curtain, a region permanently hidden. Not because it wants to be mysterious, but because the universe is expanding. And expansion rewrites what can be connected. When we observe distant galaxies, we are not seeing where they are. We are seeing where they were. Billions of years ago, we are watching ancient light from objects that may already be unreachable. Some galaxies we see today are already beyond our event horizon. Their current light will never reach us. We are receiving their final visible messages, their last echoes. This means our sky is a historical archive. Every telescope image is a time machine. Every deep field photo is a fossil record of cosmic history. When astronomers aim their instruments deeper, they are not looking farther in space. They are looking backward in time, toward the birth of structure, toward the first stars, toward the moment light first escaped into space. And yet, no matter how far we look, there will always be a final layer, a last wall of visibility. Beyond it lies unobservable reality, still existing, still evolving, but permanently silent to us. This boundary defines the maximum size of our knowable universe, not the maximum size of existence, only the maximum size of what can ever interact with us. This is the difference between the universe and the observable universe. One is everything that exists. The other is everything that can ever be known. And those two are not the same. As expansion continues, this difference grows larger. More reality becomes unreachable. More regions fade into permanent separation. The universe is not only expanding, it is fragmenting causally, breaking into isolated domains of information. We are living in a brief window, a cosmic moment where we can still observe billions of galaxies, where the sky is still crowded, where the universe is still visible. This window will not last forever. But right now, we are here, at the center of our observable bubble, surrounded by ancient light, standing at the boundary of the visible cosmos. And this is only the beginning, because next we will go deeper. We will explore what happens at the very edge itself, what the horizon really is, how it behaves, and why crossing it is impossible, no matter how fast you travel. The edge of the observable universe is not a wall. It is not a barrier made of matter. It is not a glowing line in space. It is a moving boundary, a horizon created by time, expansion, and the speed of light. To understand it, we must understand how motion works in an expanding universe. In everyday life, speed has a limit. Nothing can move faster than light through space. That rule comes from relativity. But the universe is not only about objects moving through space. Space itself can stretch. And when space stretches, distances can increase faster than light. Not because anything is breaking the speed limit, but because the road itself is growing longer. Imagine drawing two dots on a rubber sheet. Now stretch the sheet. The dots move apart, not because they are moving, but because the surface between them expands. This is what happens between galaxies. On large scales, galaxies are not racing through space. They are being carried apart by expanding space. The farther away a galaxy is, the faster it recedes from us. This is called Hubble expansion. At small distances, the recession speed is slow. At larger distances, it increases. Eventually, there is a distance where the recession speed reaches the speed of light. Beyond that distance, space expands faster than light can travel. This distance is not fixed. It changes over time. It defines the cosmic horizon. Light emitted beyond this point cannot overcome the expansion. It tries to move toward us. But space stretches faster than the photon can cross the gap. The light is pulled away, not destroyed, not absorbed, just forever delayed. This creates the cosmic event horizon, a boundary of permanent disconnection. Even if a civilization beyond that horizon sends a laser directly at Earth, perfectly aimed with infinite power, it will never arrive. Not because the signal is weak, but because space-time itself prevents connection. This is a hard limit. Unlike technological limits, it cannot be bypassed. You cannot build a faster engine. You cannot use better materials. No shortcut exists. Because the problem is not speed, it is geometry. Now imagine trying to travel to the edge. You board a spacecraft, you accelerate, you approach the speed of light, you head straight toward the farthest visible galaxies. What happens? At first, you make progress. Nearby galaxies grow larger, structures shift, but the horizon does not stay still. It moves. As you travel, the universe continues expanding. The edge keeps retreating. You can never catch it, no matter how long you travel, no matter how close you get to light speed. The horizon always remains ahead. This is similar to chasing the horizon on Earth. You can drive toward it, you can fly toward it, but it never gets closer because it is defined by perspective and geometry. The cosmic horizon works the same way. It is not a place, it is a condition, a relationship between time, distance, and expansion. Even stranger, the observable universe is not symmetric in time. There is a past horizon and a future horizon. The past horizon defines the oldest light we can see. The future horizon defines what will ever be able to affect us. These two boundaries are not the same. Right now, we can see some galaxies that will never be able to send us new light again. We are seeing their past, but we will never see their future. They have crossed the event horizon. Their current reality is already disconnected from ours. This creates a strange situation. We are observing objects that no longer share the same causal universe as us. They are visible, but unreachable, connected by ancient light only. This is why the sky is a record of lost connections, a map of regions already slipping away. Every deep space image contains objects that are already beyond our future reach. We are looking at farewell snapshots. Now, consider what happens as time continues. Dark energy keeps accelerating expansion. The horizon slowly shrinks in terms of accessible volume. More galaxies cross the boundary. The observable universe becomes emptier. In the far future, astronomers will see only a few nearby galaxies. The cosmic microwave background will fade. Expansion will stretch it beyond detectability. Future scientists may have no evidence that the universe was once larger. They may believe their small cosmic island is all that exists, not because the universe changed, but because information became unreachable. This is one of the strangest consequences of cosmic expansion. Knowledge itself has an expiration date. There is a limited window in which the universe can be studied. We happen to live during one of the best times, when galaxies are still visible. when background radiation is still measurable, when cosmic history is still accessible. This is called the cosmic coincidence. We live at a moment when the universe is both old enough to form structure and young enough to still be observable. This will not last. Now let's look closer at the horizon itself. What does it look like? From our perspective, it appears as a sphere around us. Every direction has its own horizon. There is no preferred center. Every observer in the universe sees themselves at the center of their own observable bubble. This does not mean we are special. It means observation depends on location. Every galaxy has its own cosmic horizon. Every civilization has its own visible universe. These observable regions overlap partially, but no single observer can see everything. This leads to a powerful idea. There is no universal observer, no cosmic viewpoint that sees the whole universe at once. Reality is fundamentally local. Knowledge is limited by position and time. Even hypothetical godlike observers made of perfect instruments would face this limit, not because they are weak, but because space-time restricts information flow. This has deep implications for cosmology. It means some parts of the universe will always remain untestable. Some theories cannot be directly verified, not because they are wrong, but because nature hides certain regions permanently. This challenges how science defines evidence. Usually, science relies on observation and experiment. But what happens when observation is physically impossible? Cosmologists must rely on indirect clues, patterns in the cosmic microwave background, statistical distributions of galaxies, tiny temperature fluctuations left from the early universe. These are the only fingerprints we have from beyond our horizon, like shadows on a wall, hints of a larger reality we cannot directly see. Now consider this. If the universe is infinite, then there are infinitely many regions like ours, infinite stars, infinite galaxies, infinite variations of cosmic history. But we can never verify this directly. Infinity may exist beyond our horizon, but it is observationally unreachable. If the universe is finite but unbounded, it may wrap around itself. Light traveling long enough could eventually return, but expansion likely prevents this from happening. Again, unreachable. The observable universe is not the full story. It is the visible chapter of a much larger book, and we only have access to the first few pages. Everything else remains unreadable. This does not make science meaningless. It makes it humbling. It reminds us that knowledge has boundaries, not imposed by ignorance, but by physics itself. As we push telescopes deeper, as we build larger instruments, as we map cosmic structure in greater detail, we approach the same horizon. Again and again, we get closer, but never cross. This is the ultimate frontier, not a planet, not a star, not a galaxy, but the limit of information. And next, we will explore something even stranger. What happens to time at the horizon? How cosmic expansion affects causality? And why the edge of the observable universe is not just a spatial boundary. It is a boundary in time itself. The edge of the observable universe is not only about distance, it is about time. Every horizon is also a clock, a limit on how far the past and future can reach. When we look into space, we are not seeing the universe as it is. We are seeing it as it was. Light takes time to travel. From the moon, it takes just over a second. From the sun, 8 minutes. From the nearest star, over 4 years. From distant galaxies, billions of years. The farther we look, the older the image becomes. At the edge of the observable universe, we are seeing light that left its source shortly after the universe became transparent. We are looking at the universe in its infancy. This creates a strange situation. The observable universe is not a snapshot. It is a layered history. Nearby objects are young. Distant objects are ancient. Everything we see is arranged in shells of time. Each distance corresponds to a different era. When astronomers observe the cosmic microwave background, they are not seeing galaxies. They are seeing the last moment when light could freely move through space. Before stars existed, before planets formed, before atoms were stable enough to allow transparency. This is the oldest visible surface of the universe, the surface of last scattering. It is the true edge of our past visibility. Nothing earlier can be observed with light, not because it did not exist, but because photons were trapped in hot plasma. The universe was opaque. This is a fundamental time boundary. Even if expansion stopped today, even if technology became perfect, we could never see beyond this moment using light. The past horizon is permanent. Now consider the future horizon. This is even more strange. As expansion accelerates, future light from distant regions will never reach us, not because of opacity, but because space expands too fast. The universe creates a future information cutoff. Some events that happen today in distant galaxies will never be observable. They occur outside our causal reach. This means that the observable universe has both a beginning and an end in time. We can only see events that occur within a certain space-time window. Everything outside this window is invisible, not hidden, not secret, just unreachable. This creates the concept of a causal diamond, a region of space-time that defines everything that can ever affect us and everything we can ever affect. This diamond grows at first. As the universe ages, more regions become observable, more light arrives. But as dark energy dominates, this growth slows, then it stops, then it reverses. Eventually, the accessible region shrinks. The causal diamond becomes smaller. The universe becomes quieter. This is the fate predicted by current cosmology. The sky will darken, not because stars go out, but because distant light can no longer reach us. Even galaxies that still exist will become invisible. They will fade beyond the horizon, one by one. This is not destruction. It is disconnection, a separation of space-time regions. Now imagine being born in the far future, trillions of years from now. Your night sky contains only a few faint stars, no cosmic background radiation, no distant galaxies, no evidence of expansion. Your civilization may conclude the universe is static and small. They would be wrong, but they would have no way to know. Because the evidence has left, the universe keeps expanding. But information does not keep up. This reveals something unsettling. Reality exists beyond observation, but science depends on observation. This creates a permanent gap between existence and knowledge. We can infer what lies beyond. We can model it. We can simulate it. But we can never confirm it directly. The horizon makes cosmology unique among sciences. It studies a system that cannot be fully observed. Now consider time itself at the horizon. From our perspective, objects approaching the horizon appear to slow down. Their light becomes redshifted, stretched to longer wavelengths, fainter. We receive fewer photons. Signals weaken. Eventually, they fade into background noise. From the object's perspective, nothing special happens locally. They do not feel a wall. They continue existing normally, but from our frame of reference, they freeze and disappear. This is similar to what happens near a black hole horizon. An outside observer never sees objects cross the event horizon. They appear to slow and fade. The cosmic horizon behaves in a related way, not identical, but governed by similar space-time geometry. This parallel reveals a deep connection between cosmology and black hole physics. Horizons are not just boundaries. They encode thermodynamic properties. They carry entropy. They have temperatures. The cosmic horizon emits extremely faint radiation, a thermal background linked to space-time expansion. This is known as horizon radiation. It is unimaginably weak, but it shows that horizons are physical, not just conceptual. They affect energy and information flow. This raises one of the deepest questions in physics. Does information crossing the cosmic horizon disappear forever? Or is it somehow preserved? In black hole physics, this leads to the information paradox. For cosmic horizons, similar questions arise. When a galaxy crosses beyond our event horizon, does its information vanish from our universe? Or is it encoded somehow in the horizon itself? Physics does not yet have a complete answer. Some theories suggest that horizons store information in subtle quantum structures. Others suggest information is effectively lost from observable reality. Either way, the result is the same. We cannot retrieve it. Now let's consider something even stranger. If the universe experienced inflation, then the observable region we see today is only a tiny fraction of the entire universe. Inflation stretched space so rapidly that regions far beyond our horizon exist that were once causally connected. In the early universe, everything was close together. Then inflation separated regions faster than light. This created huge domains that will never reconnect. This means the observable universe is not the full universe even in principle. It is a tiny island in a much larger cosmic ocean. Our horizon is not a natural boundary of existence. It is a consequence of our position in space-time history. If inflation occurred differently, our observable universe would look different. This suggests that different regions of the larger universe may have different physical conditions, different particle properties, different constants, different cosmic histories. This idea leads to the multiverse hypothesis, not science fiction, but a possible outcome of inflation theory. We cannot see these other regions, but their existence may be encoded indirectly in statistical patterns of the cosmic background radiation. Small anomalies, tiny asymmetries, subtle irregularities. These may be fingerprints of a larger structure beyond our horizon, but interpretation remains uncertain. Cosmology is pushing against the edge of testable science, not because scientists lack creativity, but because space-time limits access. We are explorers trapped inside a bubble of visibility. We can study its interior in extraordinary detail, but the exterior remains hidden. This is not failure. It is the nature of reality. The universe allows observation, but not total access. And this raises a final question. Is the horizon permanent? Or could new physics one day allow information to cross it? Could faster-than-light phenomena exist? Could wormholes bypass expansion? Could space-time geometry change? Current physics says no. Relativity forbids faster-than-light travel. Dark energy seems stable. The horizon appears permanent. But physics has surprised humanity before. Quantum mechanics once seemed impossible. Black holes once seemed absurd. The limits we see today may not be final. However, until new evidence appears, the observable universe remains the largest accessible region of reality, a finite bubble of information, floating in an unknowable expanse. And next, we will confront the biggest question of all. What does it mean to live inside a universe that cannot be fully known? And how does this change humanity's place in the cosmos? Living inside an observable universe changes how we think about reality, not emotionally, physically. It means the universe is not something we can fully access. It means there are parts of existence that will never interact with us. Not later, not someday, never. This is not philosophy. It is geometry. It is the structure of space-time itself. For most of human history, people assumed the universe was small. Stars were close. The sky was a dome. Everything revolved around Earth. Then telescopes expanded our vision. The universe grew larger. Galaxies appeared. Distances multiplied. But even then, people believed that with better tools, everything could eventually be seen. The observable universe changed that assumption forever. It introduced a permanent limit, a boundary that does not depend on technology, a boundary that does not depend on intelligence, a boundary that does not depend on effort, only on physics. This forces a new understanding of knowledge. There are things that exist but can never be verified directly. There are regions of space that can never be contacted. There are events that happen but leave no trace in our observable bubble. This does not make them unreal. It makes reality larger than observation. This idea is uncomfortable. Science is built on testability, on measurement, on reproducibility. But the horizon creates a category of existence beyond experimental access. This does not break science, but it reshapes it. Cosmology becomes a science of inference, patterns, statistics, indirect evidence. We cannot touch the edge, but we can see its imprint. We can detect how expansion behaves. We can measure background radiation. We can observe how galaxies move. From these clues, we reconstruct the invisible, like archaeologists studying ruins, except the ruins are written in space-time itself. Now consider what this means for our place in the universe. We are not at the center of everything, but we are always at the center of our observable bubble. Every observer is. This is not special. It is inevitable. No matter where you are in the universe, you will always see yourself at the center of your visible region. This destroys the idea of a universal reference point. There is no cosmic throne, no absolute location, only local perspectives. Reality is decentralized, fragmented into overlapping horizons. Each observer carries their own version of the universe, not different laws, not different physics, but different accessible regions. Two civilizations separated by enough distance may never know each other existed, not because they were destroyed, but because expansion erased the possibility of connection. This creates cosmic loneliness, not emotional loneliness, physical isolation. In the far future, civilizations will be trapped inside shrinking observable islands. They may develop advanced science, advanced technology, advanced understanding, yet their universe will appear small. They will never know how vast it once was. History itself becomes unreachable. The early universe will fade from view. The cosmic background will stretch into undetectable wavelengths. Evidence of expansion will disappear. Future scientists may conclude the universe is static, not because it is, but because all dynamic evidence is gone. This means we're living in a privileged era, not special, but rare. We exist during a time when cosmic history is still visible, when distant galaxies still glow, when background radiation still whispers the story of creation. This window will close, not violently, not suddenly, but quietly, as light fades, as horizons tighten. Now think about exploration. Humanity dreams of traveling far, colonizing stars, reaching other galaxies. But cosmic expansion imposes ultimate travel limits. We can reach nearby stars, nearby systems, even neighboring galaxies like Andromeda. But beyond local groups, expansion dominates. Some regions will always recede faster than we can chase. No engine can outrun expanding spacetime. This sets a maximum reachable universe, even with perfect technology, even with near light speed travel. The reachable cosmos is smaller than the observable cosmos. We can see farther than we can ever go. We are surrounded by unreachable destinations, beautiful, visible, forever distant. This is one of the cruelest truths of cosmology. The universe shows us wonders we cannot touch. Now consider communication. Signals obey the same rules. Radio waves, lasers, quantum signals, all limited by space-time geometry. Some civilizations could exist beyond our horizon right now, sending messages, broadcasting signals, but none will ever reach us, not because they are weak, but because the universe itself blocks connection. This means the search for extraterrestrial intelligence is limited not only by technology, but by cosmic structure. We can only detect civilizations within our causal region. The rest may exist, but remain silent forever. This changes how we think about loneliness in the universe. We may not be alone globally, but we may be alone locally. Now think about fate. The observable universe is not static, it evolves. As dark energy accelerates expansion, the visible region shrinks in accessible influence. We become more isolated over time. Eventually, only gravitationally bound structures remain visible. The Milky Way and Andromeda will merge, forming a giant elliptical galaxy. Other galaxies will disappear beyond the horizon. The sky will grow emptier, darker, simpler, not because stars stop forming, but because information stops arriving. This is not heat death. This is visibility death, a universe that still exists, but becomes observationally silent. Now consider the ultimate philosophical impact. If reality extends beyond observation, what does it mean to know something exists? Science usually defines existence by measurement, but here, existence is independent of measurement. Regions exist that will never be measured, never detected, never confirmed. Yet physics predicts them. Mathematics describes them. Models require them. This forces a shift in thinking. Reality becomes larger than evidence. Truth becomes partially inaccessible. This does not make science weaker. It makes it more honest. It acknowledges that the universe is not obligated to reveal itself completely. There is also a strange symmetry here. Humans cannot see beyond the horizon, but observers beyond our horizon cannot see us either. We are mutually invisible, mutually unreachable, separate islands of reality. This means there is no single shared cosmic experience. Different regions live in different observational universes, not different physical universes, but different accessible ones. This fragmentation of visibility may increase with time. As expansion continues, as horizons tighten, the universe becomes more divided, more isolated, more silent. Yet inside each observable bubble, life may thrive, stars may shine, civilizations may rise, but each bubble becomes its own island of meaning. Now think about the edge itself again. It is not a dramatic boundary, no explosion, no wall, no visual barrier, just gradual fading, redshifting, dimming, disappearing. This makes the horizon psychologically unsettling. There is no clear moment of separation, no final goodbye, only slow loss of connection. This mirrors how the universe handles change, not with drama, but with quiet inevitability. And this leads to the final question. If we can never cross the horizon, if we can never see beyond it, if we can never interact with what lies outside, does it matter? The answer is yes, because even unreachable regions influence our understanding. They shape our theories. They affect how we interpret cosmic evolution. They redefine humanity's place in existence. We are not at the center of everything. We are inside a limited window of reality, a small, accessible region in a much larger unknown. And this realization is not depressing. It is humbling. It reminds us that the universe is bigger than our perspective, that mystery is not a failure of science. It is a feature of reality. And next, we will confront the final implication. What happens if the expansion never stops? What the far future of the observable universe looks like, and how the horizon ultimately reshapes the fate of everything we can ever see. If expansion continues forever, the observable universe will not end in fire. It will end in silence, not sudden, not dramatic, but slow, gradual, relentless. Right now, the universe is filled with light. Galaxies glow, stars burn, radiation travels freely. But this is temporary. Dark energy is stretching space faster and faster. And over cosmic time, this stretching changes everything we can observe. At first, the changes are subtle. Distant galaxies become redder. Their light stretches to longer wavelengths. Energy thins. Signals weaken. Astronomers must build more sensitive instruments just to see what was once obvious. Then, entire galaxy clusters begin to fade, not because they disappear, but because their light can no longer reach us. They cross the cosmic event horizon. They are removed from our future forever. From Earth, it looks like they slowly dim and vanish, one by one, like stars fading at dawn. Eventually, only the nearest gravitationally bound structures remain visible. The Milky Way, Andromeda, a few nearby dwarf galaxies. Everything else is gone from view. The sky becomes empty, dark, simple. Future observers will see a quiet universe. They may never suspect that billions of galaxies once filled the sky. This creates a strange inversion of cosmic history. The early universe was hot and dense. The middle age of the universe is bright and structured. The far future becomes cold and empty. Not because matter vanishes, but because expansion separates everything beyond interaction. This is the era of cosmic isolation. Civilizations that exist far in the future will be trapped inside small cosmic islands. Their observable universe will shrink, not physically, but informationally. Knowledge of the wider cosmos will be impossible. Records may exist, ancient data archives, old observations, but without new confirmation, these may be dismissed as myths. Future scientists may debate whether other galaxies ever existed. With no observational evidence, certainty disappears. This shows how fragile knowledge can be. Not fragile because of ignorance, but fragile because of cosmic structure. Even truth can fade. Now consider the cosmic microwave background. This radiation is one of the most important discoveries in cosmology. It proves the universe had a hot beginning. It reveals early structure. It confirms expansion. But as time passes, this radiation stretches. Its wavelength grows longer. Its temperature drops. Eventually, it becomes undetectable, blending into background noise. The signature of the Big Bang vanishes from view. Future observers will have no direct evidence of cosmic origin. They may believe the universe always existed in its current state, not because they are wrong thinkers, but because the universe hides its history. This creates a disturbing realization. We are living during a narrow window of cosmic clarity, a time when evidence is still accessible, when the universe still tells its story. This window will close, not violently, quietly, like a book slowly fading. Now imagine the farthest future. Trillions of years ahead, stars stop forming, gas is exhausted, galaxies become collections of dead stars and remnants, black holes dominate mass distribution, expansion continues, horizon isolation increases. Even local groups become more isolated internally. Gravity weakens over large scales. Everything spreads apart. Eventually, only bound structures remain, and even those may decay. If protons decay, matter itself dissolves. If black holes evaporate through Hawking radiation, even the last massive objects fade. The universe approaches heat death, maximum entropy, no usable energy gradients, no structure capable of sustaining complexity. But before heat death fully dominates, the observable universe becomes functionally empty. Not empty of matter, empty of accessible information. This is important. The observable universe does not die when stars die. It dies when connection dies, when light can no longer travel between regions, when causality fragments, when communication becomes impossible. This is the true end of cosmic interaction. Now consider something even stranger. As the observable universe shrinks in accessible volume, each observer becomes more isolated. Civilizations separated by cosmic expansion cannot interact, not by war, not by collapse, but by geometry. Space itself pulls them apart. This makes the universe fundamentally lonely at large scales. Not emotionally lonely, structurally lonely. Reality becomes divided into isolated bubbles, each with its own history, its own evolution, its own fate, but no shared story. This is the opposite of the early universe. In the beginning, everything was close, connected, causally interacting. Now, everything separates, fragments, divides. Expansion reverses cosmic unity. This process is irreversible unless dark energy changes behavior, unless physics shifts, unless the universe transitions into a new phase. Some theories propose that dark energy may decay, that expansion could slow, that the horizon could stop shrinking. Others suggest that expansion could accelerate further, leading to a big rip, where galaxies, stars, planets, and even atoms are torn apart by spacetime expansion. Current evidence favors slow acceleration, not catastrophic ripping, but even slow acceleration is enough to isolate the universe. Now consider the psychological impact. Human civilization is built on expansion, exploration, connection, communication. But the universe is moving in the opposite direction. It is closing off regions, reducing reachable space, limiting interaction. This is not something humanity can stop. We cannot change cosmic expansion. We cannot manipulate dark energy. We are passengers inside a space-time structure beyond control. This forces a humbling realization. No matter how advanced civilization becomes, it will always be limited by the geometry of the universe. There is no technological escape, no warp drive loophole, no hidden shortcut. The horizon is absolute. It does not care about ambition. It does not respond to intelligence. It exists because space-time evolves. Now think about meaning. If the observable universe shrinks, if cosmic history fades, if connection disappears, does anything we do matter? This question often arises in cosmology, but the answer is not pessimistic. Meaning does not require infinite scale. It requires experience, interaction, awareness. Even inside a shrinking observable universe, life can exist, civilizations can develop, knowledge can grow locally. The universe may become quiet globally, but locally, complexity remains possible for a very long time. Billions, trillions of years. The horizon limits scale, not significance. This is an important distinction. Now consider the present again. We are here, at a moment when the universe is still visible, still rich with structure, still filled with galaxies. We can study cosmic expansion, measure dark energy, map the large-scale structure. We can record the universe while it is still accessible. This makes our era special, not in importance, but in opportunity. We have access to information future civilizations will never see. We are witnesses to a cosmic phase that will never return. This gives modern cosmology a strange responsibility to document the universe, to preserve its story, to capture data that will someday be unreachable. We are archivists of cosmic history, not because we chose to be, but because we exist at the right time. And this leads to the final consequence. The observable universe is not just a boundary. It is a countdown, a slow timer, marking the gradual loss of cosmic visibility, not to destruction, but to isolation. And next, we will confront the most unsettling implication of all. If reality extends far beyond what we can ever observe, if most of the universe will always remain unreachable, then what does it truly mean to say we understand the universe at all? Understanding the universe when most of it is unreachable forces a radical shift in how knowledge itself is defined. For centuries, science was built on the assumption that with enough time, enough tools, and enough intelligence, anything could eventually be measured. Mountains could be climbed, oceans could be crossed, atoms could be split, galaxies could be photographed. But the observable universe introduces a new category of limitation. Not practical, not technological, fundamental. There are things that cannot be measured, not because we lack ability, but because space-time itself prevents interaction. This means cosmology operates differently than other sciences. In chemistry, you can repeat experiments. In biology, you can observe living systems directly. In astronomy, you can point telescopes. But when it comes to the edge of the universe, repetition becomes impossible. We only get one sky, one observable bubble, one chance to observe cosmic history. We cannot rerun the universe. We cannot change initial conditions. We cannot access alternate regions. This makes cosmology closer to forensic science than laboratory science. Scientists reconstruct the past using evidence left behind in radiation patterns, galaxy distributions, and particle relics. They study fossils of space-time. The cosmic microwave background is one such fossil. Large-scale structure is another. Gravitational waves are another. These signals allow scientists to infer processes that happened billions of years ago. But inference has limits. At some point, uncertainty becomes unavoidable, and that uncertainty grows as we approach the horizon. The farther away we look, the more stretched and distorted the information becomes. Photons lose energy, signals blur, noise increases. At extreme distances, information becomes incomplete. We are reading a damaged record of the universe. This raises a critical question. How much can we truly know? The observable universe allows us to measure expansion rate, matter density, dark energy influence, and early fluctuations, but it does not allow us to see the full global shape of the universe. We do not know if space is infinite. We do not know if it curves back on itself. We do not know what lies beyond the inflation boundary. We do not know whether our observable region is typical or unusual. We only see one sample, one patch, one realization of cosmic initial conditions. This is like trying to understand an entire forest by looking through a single window. You can see trees, you can measure density, you can analyze patterns, but you cannot see the whole landscape. You cannot know what lies beyond the visible area. This does not make the effort meaningless. It makes it incomplete. And acknowledging incompleteness is a sign of scientific maturity. Now consider how this affects theories. Cosmological models rely on assumptions. One key assumption is the cosmological principle. It states that on large scales, the universe is homogeneous and isotropic. In simple terms, the universe looks roughly the same everywhere. But we cannot verify this beyond our horizon. We assume it because it matches observations within our region, but we cannot test it globally. This introduces unavoidable uncertainty into our understanding of reality. It means some parts of cosmology rest on extrapolation, not speculation, not guesswork, but extension beyond direct evidence. This is necessary, but it must be recognized. Another consequence involves the nature of physical constants, the speed of light, the strength of gravity, the charge of the electron, the mass of particles. We measure these values locally. We assume they are universal. But beyond the horizon, we cannot verify this. Some theories suggest constants could vary in different regions of the larger universe. If true, then our observable universe is just one version of reality, one local configuration. Again, this cannot be directly tested, but it influences how scientists interpret fine-tuning and cosmic structure. This uncertainty does not weaken physics. It strengthens humility. It reminds researchers that models are tools, not absolute truth. They describe accessible reality, not necessarily total existence. Now think about the role of observation itself. In quantum mechanics, observation affects outcomes. In cosmology, observation is limited by space-time geometry. This creates a layered reality. What exists? What can be observed? What can be measured? These are not identical sets. This separation changes how truth is defined. Truth becomes conditional on access. What is true within the observable universe may not represent the whole. This is not relativism. It is structural limitation. Now consider the psychological impact. Humans naturally want completeness, closure, final answers. But the observable universe denies finality. There will always be unknown regions, always unreachable domains, always unanswered questions. This can feel uncomfortable, but it also preserves wonder. Mystery is not a flaw. It is an intrinsic feature of the universe. Without mystery, exploration would end, science would stagnate, curiosity would fade. The horizon ensures that curiosity never fully dies. There is always something beyond reach, always something larger, always something unknown. Now think about communication between civilizations inside the observable universe. Even within our horizon, communication is limited by time. Signals take years to reach nearby stars, thousands of years to reach distant systems, millions of years to cross galaxies. Civilizations separated by large distances cannot have real-time dialogue. They exchange historical messages, not conversations. This limits cooperation on cosmic scales. It means that even within the observable universe, unity is limited. Connection becomes weaker with distance. This reinforces the idea that cosmic scale civilization is constrained not by ambition, but by physics. There is no galactic internet, no universal network, only isolated pockets of intelligence. This makes local cooperation more important. Planets, star systems, local clusters. These are the scales where interaction remains possible. The observable universe sets the maximum, but practical civilization exists far below that. Now consider the paradox of scale. The universe is unimaginably large, yet what matters most to life occurs on small scales. Planets, stars, local environments. The horizon shows that while cosmic structure is vast, meaningful interaction happens locally. The rest is context, background, stage. This does not reduce the importance of cosmology. It reframes it. Cosmology tells us where we are, not where we can go. Now consider humanity's future again. As expansion continues, the observable universe becomes quieter, but inside gravitationally bound regions, life can persist. Stars will continue forming for billions of years. Planets will exist. Energy gradients will remain. Civilizations can grow. The horizon does not eliminate local complexity. It only limits cosmic connection. This means meaning does not require infinite access. It requires local structure, time, energy, information flow. As long as these exist locally, life can flourish. Now think about legacy. Humanity is building telescopes, recording data, mapping galaxies, studying background radiation. We are creating a record of the universe that future civilizations may never independently verify. We are preserving cosmic memory. This gives present-day cosmology a strange role. We are not only discovering, we are archiving. We are storing evidence of a universe phase that will vanish. Future civilizations may rely on ancient data to understand cosmic origins. Our observations may become priceless, not because they are old, but because they are irreplaceable. Once the horizon hides cosmic history, no new data can replace it. This gives urgency to exploration, not urgency of fear, but urgency of opportunity. We exist during a time when the universe is still visible. That time will not last forever. Now return to the core idea. The observable universe is not just a boundary in space. It is a boundary in knowledge, a limit on what can ever be known directly. It separates existence into two categories: what we can study and what we can only imagine. This does not make imagination unscientific. It makes it necessary. Models, simulations, theoretical frameworks, these become bridges to unreachable regions. Not perfect bridges, but the only ones available. And finally, this leads to the deepest implication. The universe is not obligated to reveal itself fully. It does not exist to be understood. It exists. Understanding is something observers attempt. within limits, within boundaries, within horizons. And the observable universe is the clearest reminder of this truth. Reality is larger than perception, larger than measurement, larger than knowledge. We are explorers living inside a visible bubble, surrounded by darkness, not because the universe is empty, but because information cannot cross the cosmic distance. And next, we will confront the final question. If the observable universe defines the hard limit of reality we can access, what lies beyond that limit? And is it truly unreachable forever? Beyond the edge of the observable universe, reality does not end. It simply becomes unreachable. This is the hardest concept to accept, not because it is complex, but because it contradicts how humans naturally think about space. We imagine edges as borders, walls, cliffs, endpoints. But the cosmic horizon is none of these. It is not the edge of existence. It is the edge of connection. What lies beyond it is not destroyed, not erased, not broken. It continues evolving. Stars still burn, galaxies still collide, time still moves forward. But none of it can ever influence us, and we can never influence it. Two regions of reality become permanently separated, not by distance alone, but by the expansion of space-time itself. Now consider the size of what we cannot see. The observable universe has a radius of about 46 billion light-years. That sounds enormous, but it may be tiny compared to the full universe. If inflation occurred as current models suggest, the total universe could be thousands, millions, or even infinitely larger than what we can observe. Our visible region may be a small bubble floating inside a much greater cosmic structure. This means most of reality may already be beyond our horizon, not hidden behind stars, not blocked by dust, but fundamentally unreachable. We are living inside a limited window of existence, surrounded by a vast unknown. This is not pessimistic. It is astonishing. It means the universe is far larger than any telescope image suggests. Now consider what this implies about uniqueness. Everything we see appears rare. Rare galaxies, rare star systems, rare conditions that allow life. But if the universe beyond our horizon is vast enough, then everything that can happen likely happens somewhere. Not because of magic, but because large numbers make rare events inevitable. If there are enough galaxies, enough stars, enough planets, then even extremely unlikely combinations occur. This leads to a disturbing possibility. There may be regions beyond our horizon that look almost identical to ours. Not similar, nearly identical. Same galaxy types, same cosmic structure, possibly even similar planetary systems. This is not science fiction. It is a statistical consequence of very large universes. If the universe is infinite, then somewhere beyond our horizon, the same patterns repeat. Not exactly, but close enough to be recognizable. This idea changes how we think about uniqueness. Our observable universe feels special, but on cosmic scales, it may be just one variation among countless others. This does not make life meaningless. It makes life statistically inevitable in large enough systems. Now consider inflation again. Inflation theory suggests that different regions of the universe may have experienced slightly different physical conditions, different rates of expansion, different energy densities, different vacuum states. This could produce regions with different physical laws, different constants, different particle behaviors. In this picture, Our observable universe is one bubble in a larger multiverse. Each bubble evolves independently. Each bubble has its own horizon. Each bubble has its own observable region. These bubbles cannot communicate. They are separated by expanding spacetime. This is not proven, but it is consistent with some inflation models, and it highlights the role of horizons again. Even if other universes exist, they remain unreachable, not hidden, not cloaked, simply causally disconnected. Now ask the most dangerous question. If we can never observe beyond the horizon, how do we know anything exists there at all? The honest answer is that we do not know. We infer, we model, we extrapolate. We take physics observed locally and extend it outward. This is not blind faith. It is logical extension, but it is not direct evidence. This is the boundary between science and philosophy. At the horizon, physics becomes inference-based, not measurement-based. This is uncomfortable for some scientists, but unavoidable. When observation ends, reasoning continues. Theories attempt to describe global reality using local data. They may be right, they may be incomplete, but they are the best tools available. Now consider something even stranger. From the perspective of a region beyond our horizon, we do not exist, not because we are destroyed, but because our light can no longer reach them. They may see ancient light from our region, a faint snapshot of our past, but they will never see our present. They will never see Earth today. They will never see human civilization. They are causally disconnected from our reality. This means reality is fragmented into observational islands. Each island sees its own version of the universe, not different physics, different access, different history, different visible past. No single observer has access to total reality. This has never happened before in human thinking. Every earlier model of the universe assumed complete access was possible. With enough travel, enough time, enough technology, the observable universe destroys that assumption. It introduces permanent separation, permanent inaccessibility, permanent unknown. Now think about the future again. As expansion continues, more regions cross beyond the horizon. Reality becomes increasingly partitioned. The universe fragments into isolated domains, each with its own fate. This process will not reverse unless dark energy changes behavior, unless expansion slows, unless space-time dynamics evolve. Current evidence suggests acceleration will continue, which means isolation will increase, not decrease. Now consider the ultimate implication. If most of reality is unreachable, if the observable universe is only a small fraction of existence, then our understanding of the universe will always be incomplete, not temporarily, forever. This does not make science meaningless. It makes science bounded. It reminds us that knowledge is local, contextual, limited by access. But within those limits, science remains powerful. We can still understand physics inside our horizon. We can still map structure. We can still predict cosmic evolution locally. We can still explore nearby space. We can still study stars, galaxies, black holes, and cosmic radiation. The horizon does not remove meaning. It removes totality. Now think about perspective. Humans often search for absolute answers, final theories, complete descriptions. But the universe does not promise completeness. It offers partial access, partial information, partial understanding. This does not reduce the value of discovery. It increases it. Because every piece of knowledge gained inside the observable universe is precious. It is part of a limited data set that will never be expanded beyond a certain point. We are collecting information that future civilizations may never be able to reproduce. Our observations are unique, time-limited, irreplaceable. This gives present-day cosmology a special role. We are living during the era when the universe is still visible, still measurable, still rich with accessible structure. That era will not last forever. Now return to the edge one last time. The observable universe is not a dramatic boundary. No flashing line, no visible barrier, just fading light, redshift, silence, gradual disappearance. This quiet ending is perhaps the most unsettling part. There is no cosmic warning, no sudden cutoff, just a slow retreat of information, like watching a short line fade into fog. The ocean still exists, but the view is gone. And this is the true meaning of the edge of the observable universe. It is not the end of reality. It is the end of access, the end of connection, the end of shared cosmic experience. We live inside a bubble of visibility, floating inside a much larger unknown, surrounded by darkness, not because nothing exists, but because space-time itself limits what can ever be seen. This is the hard limit of reality, not because reality stops, but because observation does. And beyond that limit, the universe continues, forever silent to us, forever unreachable, forever unknown. The most unsettling truth about the observable universe is not that there is an edge. It is that the edge is permanent. There is no map that leads beyond it, no technology that bypasses it, no future breakthrough that makes it disappear. It is built into space-time itself. This forces humanity to confront a limit unlike any before. Every other boundary in history was temporary. Oceans were crossed, mountains were climbed, the atom was opened, the genome was decoded. But the cosmic horizon is different. It is not a challenge waiting to be solved. It is a condition of reality. Now consider what this means for exploration. Human civilization has always expanded outward, across continents, across oceans, into orbit, toward the stars. Exploration defines identity, progress, ambition. But the observable universe sets a final frontier, not a destination, a boundary of reach. We can explore within our local cosmic neighborhood. We can reach nearby star systems. We can map the Milky Way. We can study neighboring galaxies. But we cannot explore the full universe. Most of reality will remain unvisited, unmeasured, untouched. Not because we failed, but because space-time forbids it. This changes the nature of ambition. It shifts the focus from infinite expansion to finite mastery, from outward conquest to inward understanding, from reaching farther to understanding deeper. Now consider communication again. Even if humanity builds powerful interstellar civilizations, communication across cosmic scales remains limited. Messages sent to distant galaxies may never arrive. Replies may never return. Civilizations become isolated by distance and expansion. This means cooperation on universal scales is impossible. There is no cosmic federation, no intergalactic society, no shared universal culture. Reality is divided into local islands of interaction, each evolving independently. This fragmentation is not emotional, it is physical, it is structural, it is permanent. Now think about time. Time itself becomes fragmented by horizons. Events happening today beyond our horizon will never be part of our future history. They will never influence us. They will never be recorded. They will never be known. They exist only locally. This creates parallel cosmic histories that never intersect. Different regions live through different futures, not separate universes, separate causal domains. This is one of the strangest consequences of expansion. The universe is not one connected story. It is many disconnected narratives unfolding simultaneously. Now consider the meaning of observation. When astronomers observe distant galaxies, they are not watching the present universe. They are watching the past. They are watching regions that no longer exist where they appear. They are observing ancient light from regions that may already be unreachable. This creates a universe made of memory. Every telescope image is a time capsule. Every deep field is a fossil record. The observable universe is not a map of space. It is a museum of time. As expansion continues, this museum closes its doors, exhibits disappear, displays fade, history becomes inaccessible. Now think about what remains. Inside gravitationally bound regions, life can persist for a long time. Stars will burn, planets will orbit, civilizations may rise and fall. Local meaning remains, but cosmic context shrinks. The universe becomes smaller in appearance, not because it shrinks, but because connection fades. This means future civilizations may never understand their true cosmic environment. They may believe the universe is small, static, unchanging, not because they are wrong thinkers, but because the universe no longer shows its larger structure. Truth becomes unreachable, not false, unreachable. This is one of the deepest consequences of the observable universe. It is not just a limit on travel. It is a limit on truth itself, not absolute truth. Local truth remains. Physics still works. Stars still behave according to laws. Atoms still obey quantum mechanics. But global truth becomes hidden. The big picture fades. Now consider the role of humanity today. We exist at a moment when the universe is still visible, when expansion has not yet erased cosmic history, when background radiation can still be measured, when distant galaxies still glow. We are living during a narrow observational window. This gives present-day civilization a strange responsibility, not to control the universe, but to record it, to document it, to preserve its story. We are the witnesses of a cosmic era that will never return. Future civilizations may depend on our records to understand where they came from. They may never see what we see. They may only read about it. This makes modern cosmology more than academic research. It becomes cosmic archaeology, preserving evidence before it disappears. Now consider perspective again. Humans often ask whether the universe has meaning, whether existence has purpose. The observable universe does not answer that question, but it reframes it. Meaning does not come from infinite access. It comes from local experience, from understanding what is reachable, from building knowledge inside boundaries. The horizon does not remove significance. It defines context. It tells us that we are small, but not irrelevant. We exist inside a vast structure, but we are part of it. We observe it. We measure it. We attempt to understand it. That effort itself becomes meaningful. Now think about humility. The observable universe is a lesson in limits, not limits of intelligence, limits of nature. It reminds humanity that we are not the center of everything, not the master of spacetime, not capable of unlimited expansion. We are participants in a cosmic system that evolves beyond our control. This is not weakness, it is realism. Now consider one last possibility. What if dark energy changes? What if expansion slows? What if the horizon shifts? Physics does not rule this out completely. Dark energy remains poorly understood. It could evolve. It could decay. It could transform. If that happens, the horizon could change. The observable universe could expand again. New regions could become visible. New connections could form. But this is speculation. Based on current evidence, expansion will continue. Isolation will increase. The horizon will remain. We must accept what we know, not what we hope. Now return to the edge one final time. It is not visible, not dramatic, not glowing. It does not announce itself. It simply exists, a boundary defined by light speed and space-time expansion, a limit that separates reachable reality from unreachable existence. We cannot touch it. We cannot cross it. We cannot see beyond it. But it shapes everything we observe, everything we measure, everything we can ever know. This is the true power of the observable universe. Not that it limits us, but that it defines our cosmic context. It tells us where we stand, inside a finite bubble of visibility, floating inside an infinite unknown, surrounded by darkness, not because the universe is empty, but because information cannot cross the cosmic divide. This is the hard limit of reality, not because reality ends, but because access ends. And beyond that limit, the universe continues silently, expanding, evolving, existing, forever beyond our reach, forever beyond our sight, forever beyond our knowing. And yet, still part of the same vast cosmos we call home. There is one final consequence of the observable universe that changes everything. It is not about distance, not about expansion, not about dark energy. It is about perspective. The fact that every observer sees themselves at the center of their own observable universe, not because they are special, but because horizons are personal. Wherever you stand in the cosmos, you carry your own bubble of visibility, your own edge, your own limits, your own version of reality. This means there is no universal viewpoint, no place in the universe where everything can be seen at once, no cosmic control room. Reality is fundamentally fragmented by observation. Each region sees only what space-time allows. This destroys the idea of a single shared cosmic picture. Instead, the universe is a patchwork of overlapping perspectives, each one incomplete, each one limited, each one locally true. Now consider what this means for objectivity. Science often aims for universal truth, laws that apply everywhere, principles that do not depend on location, and those laws still exist. Gravity behaves the same. Light follows the same rules. Quantum mechanics applies everywhere, but access to information does not. Two civilizations separated by enough distance will never agree on what the universe looks like, not because they disagree scientifically, but because they see different parts of reality. Their skies contain different galaxies. Their cosmic histories appear different. Their observable universes do not overlap. Both descriptions are correct, but incomplete. This creates a strange form of cosmic relativity, not just of motion, but of knowledge. Truth becomes layered. Local truth remains accurate. Global truth remains unreachable. Now imagine a civilization far beyond our horizon. They have their own telescopes, their own scientists, their own cosmic background radiation, their own observable universe. They may discover expansion, dark energy, cosmic structure, just like us. But their sky contains different galaxies, different patterns, different histories. They will never know about the Milky Way, they will never know about Earth. They will never know about humanity. Not because we are insignificant, but because space-time prevents connection. We exist in the same universe, but not in the same accessible reality. This is the most unsettling implication. The universe is shared, but experience is isolated. Now consider communication again. Even within our horizon, time delays limit interaction. Between stars, communication takes years. Between galaxies, millions of years. Between distant clusters, billions of years. Conversations become impossible. Only historical messages remain. The universe is not built for dialogue at large scales. It is built for separation. This suggests that intelligence in the universe will always be local, never global, never unified across cosmic distances. There will never be a universal civilization, only islands of awareness, separated by expanding space-time. Now consider the emotional response to this idea. It often feels lonely, empty, cold. But this reaction comes from human expectations. We evolved on a small planet, in a connected environment. We expect connection to scale upward, but the universe does not follow social intuition. It follows geometry, expansion, causality, and those do not care about emotional meaning. Yet meaning still exists, not at cosmic scale, at local scale. Inside stars forming planets, inside planets hosting life, inside minds capable of understanding. Meaning does not require infinite reach. It requires awareness, interaction, experience. These remain possible even inside a shrinking observable universe. Now consider the role of memory. As cosmic history fades from view, memory becomes the only connection to the larger universe. Records, data, archives, stories. Humanity is building the memory of the cosmos. Telescopes capture light that will never return. Detectors measure radiation that will fade. Maps record structure that will disappear. We are preserving a snapshot of a cosmic era, not because it is beautiful, but because it is temporary. This transforms astronomy into preservation, not just exploration. We are not only learning, we are saving knowledge before it becomes unreachable. This gives modern science a strange urgency, not panic, but responsibility, to document, to store, to protect. Future civilizations may depend on these records to understand cosmic origins. They may never see the early universe themselves. They may never measure background radiation. They may never observe distant galaxies, but they may read about them, study ancient data, reconstruct lost history. This makes our era uniquely important, not special, but positioned. We exist during the era of maximum cosmic visibility. Now think about the final philosophical shift. The observable universe forces humanity to accept incompleteness, not ignorance, incompleteness. There will always be unknown regions, always unreachable reality, always unanswered questions. This is not failure. It is structural. It is built into space-time. Science can approach truth, but never fully encompass it. This does not weaken science. It makes it honest. It acknowledges limits. It accepts uncertainty. It continues exploring within boundaries. This is maturity. Now return to the original idea. The edge of the observable universe is the hard limit of reality we can access, not the end of existence, the end of connection, the end of information flow. Beyond it, reality continues, but silently, forever outside our causal reach, forever unobservable, forever disconnected. We will never see what happens there, never measure it, never interact with it, but it exists. And that fact alone changes how we view the universe. It becomes larger than observation, larger than perception, larger than knowledge. Now consider humanity's place one last time. We are not at the center of the universe, but we are at the center of our observable bubble. We are surrounded by ancient light, standing inside a cosmic window that will slowly close. We are witnesses to a temporary phase of visibility, a brief moment when the universe is open to observation. This moment will pass, not with catastrophe, but with quiet fading, as light stretches, as galaxies disappear, as horizons tighten. But right now, we are here, alive, aware, looking outward, trying to understand, trying to map reality inside the boundaries given to us. This is not small, this is extraordinary, because even inside a limited bubble of visibility, we can still comprehend the structure of the cosmos. We can still measure its expansion. We can still trace its history. We can still ask questions. We can still seek meaning. The observable universe may be finite, but curiosity is not. And that is the final truth. The universe sets boundaries. Spacetime limits access. Horizons restrict knowledge. But inside those limits, consciousness still rises. Understanding still grows. And even at the edge of everything we can ever see, we continue to look outward, not because we will reach the other side, but because the act of looking defines what it means to be human, standing at the boundary of reality, staring into the unknown, knowing we cannot cross it, yet still trying to understand what lies beyond. This is where the journey ends, not because there is nothing more to say, but because there is nothing more that can be reached. The observable universe is not a place you arrive at. It is a condition you live inside, a boundary that follows you wherever you go, a horizon that moves with your position in space-time. You cannot escape it. You cannot outrun it. You cannot step beyond it. No spacecraft can cross it. No signal can bypass it. No civilization can overcome it. It is written into the geometry of reality itself. And once this is understood, everything changes. For most of history, humanity believed the universe was something to be conquered, mapped, explored completely, understood in total. But the observable universe proves something different. The universe is not fully accessible, not fully knowable, not fully reachable. It is larger than any observer, larger than any civilization, larger than any possible future technology. This does not make the universe hostile. It makes it vast, and it makes our place inside it precise. We are not meant to experience everything. We are meant to experience what is reachable. Now consider what remains within our horizon. Stars will continue to burn. Planets will continue to orbit. Life will continue to arise and evolve. Inside gravitationally bound regions, structure persists. Meaning persists. History continues. The observable universe does not remove purpose. It removes the illusion of total access. It teaches that existence does not require completeness, only presence, only interaction, only awareness. Inside this cosmic bubble, consciousness emerged. On a small planet around an ordinary star, in a galaxy among billions, in a universe far larger than imagination. Yet from this small position, humanity measured cosmic expansion, detected background radiation, mapped galaxies billions of light years away, discovered the shape of space-time itself. This is extraordinary, not because humans are powerful, but because understanding is possible at all. Inside a limited region of reality, minds formed that could comprehend the structure of the whole, even knowing that the whole can never be fully accessed. That is the real miracle. Now think about the future again. As time passes, horizons tighten, light fades, cosmic information disappears, but inside this shrinking window, knowledge can still grow. Civilizations may become more advanced. Science may become more refined. Understanding may deepen locally. The universe becomes quieter globally, but richer locally. This is not decline, it is transformation. Now return to the edge one last time. It is not visible, not dramatic, not marked by anything physical. It exists only as a limit on the information, a silent boundary, a horizon of causality, a wall made not of matter, but of space-time expansion. Beyond it, the universe continues. Stars explode, galaxies merge, new structures form, but none of it can ever reach us, and none of what happens here can ever reach them. Two parts of the same universe, forever separated, forever disconnected, forever unreachable. This is not tragedy, it is reality. Now consider the deepest implication. The observable universe teaches that reality does not exist to be observed, it exists independently. Observation is a local phenomenon, limited, contextual, bound by physics. The universe does not care whether it is seen. It expands, it evolves, it exists. And inside a small region of it, awareness appeared. Awareness that can ask questions, build telescopes, measure radiation, understand expansion, and even recognize its own limits. This may be the most remarkable outcome of cosmic evolution. Not stars, not galaxies, not black holes, but the emergence of minds capable of understanding that they live inside a bounded reality. Now imagine standing beneath the night sky, looking at distant galaxies, knowing that many of them are already unreachable, knowing that their light is ancient, knowing that some of them no longer share the same future as us, and still choosing to observe, still choosing to study, still choosing to understand. That choice is what defines science, not the promise of complete answers, but the pursuit of understanding within limits. The observable universe does not end curiosity, it sharpens it. It tells us that knowledge is precious, time-limited, finite, and therefore valuable. Every photon collected is irreplaceable. Every measurement is unique. Every observation is part of a cosmic record that will never be repeated. We are living during the era when the universe is still visible, still measurable, still open to observation. This era will pass, quietly, gradually, without warning. But right now, it exists, and we are inside it. This is the final truth of the observable universe. Not that it limits us, but that it gives us context. It tells us where we stand, inside a finite bubble of visibility, floating inside an infinite unknown, surrounded by darkness not because nothing exists, but because space-time itself limits connection. This is the hard limit of reality, not the end of existence, not the end of the universe, but the end of access, the end of reach, the end of shared cosmic experience. Beyond it, the universe continues silently, forever expanding, forever evolving, forever unreachable. And inside it, we continue to look outward, not because we can cross the boundary, but because understanding what lies within it is enough to define who we are, standing at the edge of everything we can ever see, knowing it is not the end of reality, only the end of what we can observe, and still choosing to look. That is where the observable universe truly ends, not in darkness, but in awareness. Even after everything has been said about horizons, expansion, limits, and unreachable regions, one question still remains. Why does the universe allow this boundary to exist at all? Why does reality permit observation up to a point, and then suddenly refuse to reveal anything more? The answer is not philosophical. It is mathematical. The observable universe exists because information has a speed limit. Light does not travel infinitely fast. Causality does not propagate instantly. Spacetime itself expands. These three facts combine to create the horizon. If light were infinite in speed, there would be no observable limit. If space did not expand, distant regions would eventually become visible. If time behaved differently, horizons would not exist. But the universe chose this structure, not consciously, not intentionally, but through physical law. This means the observable universe is not an accident. It is a natural consequence of how reality is built. And once this is understood, the horizon becomes more than a boundary. It becomes a feature of the universe's design. Now consider the relationship between simplicity and complexity. The universe begins simple, hot, dense, uniform. Then it expands. Structures form, galaxies emerge, stars ignite, planets condense, life appears, complexity increases. But as expansion continues, large-scale structure fades, connection decreases, isolation grows. In the far future, simplicity returns, cold, sparse, quiet. This is the full arc of cosmic evolution, from simplicity to complexity, and back to simplicity again. The observable universe marks the midpoint of this story, the era when complexity peaks, when structure is visible, when information is accessible, when observation is possible. We are living inside that peak. This is not coincidence. It is timing. Human civilization exists during the most observationally rich era the universe will ever have. Not the hottest, not the densest, but the most transparent, the most readable, the most open to study. Now consider what happens when this era ends, when galaxies fade beyond view, when background radiation disappears, when cosmic expansion erases large-scale evidence. Future civilizations may never know the universe had a beginning. They may never detect the Big Bang. They may never measure expansion directly. They may believe the universe is static and eternal, not because they are wrong, but because evidence will be gone. This creates a strange inversion of scientific progress. Technology may advance, knowledge may grow locally, but cosmic understanding may decline, not through ignorance, through loss of access. This is unprecedented. Never before has knowledge become unreachable because of space-time itself. Now consider the emotional weight of this idea. It can feel tragic, like losing a window to reality, like watching knowledge slip away. But it can also be seen differently, as a reminder that observation is temporary, that access is precious, that the present moment matters. We are not guaranteed unlimited time to study the universe. We are borrowing light from distant galaxies that will never send another photon. We are collecting information from regions that will soon vanish beyond reach. This makes present observation incredibly valuable. Every dataset is a snapshot of a universe phase that will never repeat. Now consider the human response to limits. When confronted with boundaries, humanity often reacts in two ways. One is frustration. The other is creativity. We cannot cross the horizon physically, but we can simulate, model, predict, infer. We can build mathematical universes inside computers. We can test cosmological models. We can explore hypothetical physics. We can extend knowledge through reasoning when observation fails. This is how science adapts. When direct access ends, indirect understanding begins. Not perfect, not complete, but powerful. Now think about imagination. The observable universe does not restrict imagination. It expands it. When the physical boundary appears, curiosity pushes outward conceptually. What lies beyond? Is space infinite? Does inflation create multiple universes? Are physical laws the same everywhere? Is our region typical? These questions cannot be directly answered, but they drive theoretical exploration. They push physics forward. They inspire new ideas. The horizon does not end science. It reshapes it. Now consider something deeper. The observable universe also defines the scale of relevance. Cosmic distances are enormous, but life happens on small scales. Atoms, cells, brains, planets, stars, local environments. The horizon shows that while the universe is vast, meaningful interaction occurs locally. This gives perspective. It reminds us that we do not need access to everything to matter. We do not need to reach infinite space to create value. Local existence is enough. Now return to the idea of connection. Even as cosmic connection fades, local connection remains. Civilizations may shrink in cosmic reach, but they can deepen internally. They can explore their own galaxies, their own star systems, their own worlds. They can build cultures, knowledge networks, artificial intelligence, long-term projects. Meaning does not disappear with isolation. It transforms. Now imagine the far future again. A civilization billions of years ahead. The sky is mostly empty. Only a few nearby galaxies remain visible. The cosmic background radiation is gone. The universe appears small. But inside that small visible region, technology may be extraordinary. Energy may be harvested efficiently. Stars may be engineered. Artificial habitats may exist. Knowledge of physics may be refined. Life continues. Complexity persists. Even as cosmic context fades. This shows that the horizon does not end progress. It ends cosmic scale ambition. It forces focus inward. Now think about the last implication. The observable universe creates a paradox of awareness. We know there is more beyond what we can see, but we will never see it. We are aware of our ignorance. This is rare in nature. Most organisms are unaware of what they cannot perceive. Humans are different. We know there is more. We know we are limited. We know reality is larger than perception. This self-awareness is itself extraordinary. It allows humility. It prevents false certainty. It encourages careful interpretation of data. It reminds us that models are approximations, not absolute truth. Now consider the ultimate question. If reality extends far beyond observation, does that make the observable universe insignificant? The answer is no, because significance is not measured by size. It is measured by experience. Everything that has ever been experienced by any conscious being exists inside an observable region. Experience happens locally. Meaning arises locally. Awareness exists locally. The rest of the universe may be vast, but it is unexperienced, unknown, untouched. The observable universe contains all experience that has ever occurred. That alone gives it importance. Now return to the beginning. The edge of the observable universe is not a wall in space. It is a limit of information, a boundary of causality, a horizon of reach. It exists not to restrict curiosity, but to define the structure of reality. It tells us what can be known, what cannot be known, what may be inferred, what must remain mysterious. And finally, it teaches one quiet truth. The universe is not built for complete understanding. It is built for partial discovery, for exploration within limits, for curiosity inside boundaries, for awareness inside a finite bubble of visibility. And that is enough, because even inside this limited region, stars still shine, planets still form, life still emerges, minds still think, questions are still asked. We do not need access to everything to find wonder. We do not need infinite space to feel awe. We do not need to cross the horizon to understand our place. We already stand inside one of the most remarkable structures in existence, a universe large enough to contain billions of galaxies, yet structured enough to allow consciousness, bounded enough to define context, open enough to inspire exploration. This is the final legacy of the observable universe. Not that it limits reality, but that it frames it. Not that it hides truth, but that it defines where truth can be discovered. And as long as there are minds looking outward, the horizon will never feel like an ending, only a reminder that the universe is bigger than us, and that understanding what we can reach is more than enough to justify the journey. At the very end of this journey, there is no explosion, no collapse, no dramatic final image. There's only stillness, not empty stillness, not dead silence, but the quiet understanding of what the observable universe truly represents. It is not a cage, not a prison, not a punishment. It is the shape of reality as experienced by observers, a bubble of visibility, a window of connection, a boundary created not by walls, but by time, light, and expansion. And once this is understood, something changes. The universe no longer feels smaller because it has limits. It feels larger because most of it will never be seen. Now consider what it means to exist inside this bubble. Every photon that reaches your eyes has traveled across expanding space. Every star you see is ancient. Every galaxy is a message from the past. You are not seeing the universe as it is. You are seeing the universe as it was. This means the observable universe is not just space. It is history layered across distance, a three-dimensional archive of cosmic time, and you are standing inside it at one tiny point, receiving information from billions of years ago. This is extraordinary, not because humans are special, but because the universe allows observation at all, because the laws of physics permit light to travel, permit matter to organize, permit consciousness to arise, permit questions to be asked. Now consider the fragility of this moment. Cosmic visibility is temporary. It is a phase, a brief era in the life of the universe when expansion, temperature, and structure align to allow observation. Before this era, the universe was opaque, hot, dense, filled with plasma that blocked light. After this era, the universe will become quiet, cold, sparse. Light will fade, information will disappear. We exist in the middle, in the only era where the universe can truly be studied. This is not coincidence. It is timing. We arrived at the right moment to witness the cosmos. Not forever, just long enough. Now think about responsibility again. Not responsibility to control the universe, but responsibility to understand it while we can, to record it, to preserve knowledge, to build archives, to map structure, to study radiation, to document cosmic history before it fades. We are not only explorers, we are witnesses. Now consider the final emotional shift. When people first learn about the observable universe, the reaction is often discomfort, a feeling of being trapped, limited, small. But over time, this feeling changes. The boundary becomes something else. Not a barrier, but a frame, like the edge of a painting. It does not limit the art, it defines it. It gives shape to what is seen. The observable universe gives shape to reality as experienced. It defines the scale of meaning, the size of interaction, the limits of connection. Inside this frame, everything that has ever been experienced exists. Every thought, every civilization, every memory, every discovery, everything meaningful to any observer exists inside an observable region. The rest of the universe may be vast, but it is unexperienced, unobserved, untouched. Meaning happens locally, not globally. Now return to humanity's place. We are not at the center of the universe, but we are at the center of our experience. We are embedded inside spacetime, carried forward by cosmic expansion, surrounded by ancient light, standing on a planet orbiting a star in a galaxy among billions. And yet, from this position, we can reconstruct the birth of the universe, measure its expansion, predict its future, understand black holes, map large-scale structure, detect gravitational waves. This is not small. This is astonishing. It means intelligence can arise inside a tiny region of space and still understand the structure of the cosmos, even knowing that most of it will remain unreachable. Now think about what remains unknown. What lies beyond the horizon? How large the universe truly is, whether space is infinite, whether other observable bubbles exist, whether physical laws vary, whether inflation produced multiple universes, whether reality has deeper layers we cannot see. These questions will never be fully answered by observation, but they will continue to shape theoretical physics. They will inspire generations of thinkers. They will push mathematics, simulation, conceptual models. The horizon does not end inquiry. It defines its next stage. Now imagine the far future one last time. Trillions of years ahead. Stars are rare. Galaxies are dim. The universe is quiet, but somewhere, perhaps inside a remaining star system, a civilization studies ancient data. Records of galaxies long vanished. Maps of cosmic background radiation that no longer exists. Images of a sky filled with light. They reconstruct a universe they cannot see. They learn about a time when the cosmos was open, bright, connected. They learn that once the universe was visible and that their ancestors lived during that era, that we lived during that era. This gives our present moment weight, not because we are special, but because we are early. We exist during the age of cosmic visibility. Now return to the edge. The edge of the observable universe is not a place you reach. It is something you carry. Wherever you go, your horizon moves with you. Your bubble of visibility follows your position. This means there is no escape from the boundary, but there is also no separation from it. It is part of your relationship with reality. It defines how you interact with the universe, how far information can travel, how much of existence can be known. This is not limitation in the human sense. It is structure in the cosmic sense. Now consider the final lesson. The observable universe teaches humility, not weakness, humility. It shows that reality is larger than any observer, that knowledge is local, that understanding is partial, that truth is approached, not possessed. This does not reduce the value of science. It strengthens it. It keeps curiosity alive. It prevents false certainty. It encourages careful thinking. It respects complexity. Now consider the final truth. The universe does not promise us infinite access. It promises existence. It promises structure. It promises laws. It promises evolution. Inside those promises, observers emerge, and those observers try to understand, even knowing they will never know everything. This is not tragic. It is beautiful, because meaning does not come from total knowledge. It comes from the attempt to understand, from asking questions, from building models, from exploring within limits, from standing at the edge of what can be seen, and still choosing to look outward. The observable universe is the final horizon of visibility, but it is not the end of wonder. It is not the end of discovery. It is not the end of curiosity. It is simply the place where observation stops and imagination begins. Beyond that boundary, the universe continues, silent, unreachable, expanding, evolving, existing. And inside this small bubble of light and matter, we exist, aware, curious, looking outward, knowing we cannot cross the horizon, yet still trying to understand what it represents. This is where the journey ends. Not with darkness, not with emptiness, but with perspective, with awareness, with the understanding that we live inside a finite window of reality, and that this window is more than enough to inspire wonder, more than enough to build knowledge, more than enough to define meaning. The observable universe is not the end of everything. It is the boundary of what we can see. And standing at that boundary, we finally understand our place, not as masters of the cosmos, not as insignificant observers, but as conscious beings living inside a vast, structured, evolving universe, doing what the universe itself seems to encourage, observing, learning, understanding, and continuing to look outward, even when the edge is all that remains visible.